1. The places where time moves differently. Have you ever looked up at the night sky and quietly wondered whether time flows the same everywhere in the universe? It feels like such a simple question, almost too simple. After all, every clock you've ever owned has moved in the same familiar rhythm. Every sunrise arrives one day after another. Every birthday comes exactly 1 year apart. Every heartbeat gently reminds us that time never seems to stop. From the moment we're born, time feels wonderfully reliable, steady, predictable, almost comforting. It's one of the few things we rarely question. We may wonder how large the universe really is. We may wonder whether life exists around distant stars. We may even imagine what it would be like to stand on another planet beneath an unfamiliar sky. But we almost never stop to ask a much stranger question. Would time feel the same once we arrived? Not simply whether the days are longer, or whether a year lasts hundreds of Earth days, but whether time itself, the invisible current carrying every moment of your life, could actually flow at an entirely different speed. Imagine for just a moment that you board a spacecraft unlike anything humanity has ever built. It leaves Earth quietly. The blue oceans slowly shrink beneath you. The moon slips behind. The sun becomes another bright star among countless others. Eventually, after an extraordinary journey, you reach a distant corner of the universe. Everything feels peaceful. The sky above you glows with unfamiliar constellations. The nights are darker than anything you've ever known. The silence is almost perfect. You spend a few comfortable years exploring this remarkable place. You watch strange sunsets. You collect fascinating rocks. You look toward your distant home, now impossibly far away. Nothing feels unusual. Your watch still ticks. You still laugh. You still sleep. You still wake each morning, believing time is moving exactly as it always has. Then one day, you decide to return home. The journey back feels no different. Perhaps another few years pass. You imagine seeing familiar cities, old friends, family members waiting patiently for your return. But when Earth finally appears through your spacecraft's window, everything has changed. The cities are gone. The languages are different. Entire civilizations have risen and disappeared. Thousands of years have quietly passed while you experienced only a handful. Not because your spacecraft traveled faster through space, but because it traveled differently through time. At first, this sounds impossible, like something dreamed up by a science fiction writer searching for the perfect ending. Yet the remarkable thing is that modern physics tells us this idea is not fantasy at all. Time is not the perfectly steady river we once imagined. It bends, it stretches, it slows, and under the right conditions, it can flow astonishingly differently from one place to another. That realization changes almost everything we think we know. The universe isn't simply a collection of planets, stars, galaxies, and black holes scattered across unimaginable distances. Hidden beneath all of them is another landscape, one we cannot see, one we cannot touch. A landscape made entirely of time itself. Every star quietly shapes it. Every planet gently influences it. Every galaxy slowly curves it. Even you are part of it. In fact, something extraordinary is happening right now. As you listen to these words, time is not passing equally throughout your own body. The top of your head is experiencing time ever so slightly faster than your feet. The difference is unimaginably tiny, far smaller than anything your senses could ever notice. Yet, with precise enough instruments, scientists can measure it. The universe has no perfectly level flow of time, not even across a single person standing perfectly still. This wasn't always how humans imagined reality. For thousands of years, time seemed absolute. Ancient astronomers carefully observed the skies. Farmers planted crops according to reliable seasons. sailors crossed oceans guided by familiar stars. Generations built calendars, clocks, and civilizations on the comforting belief that every second was identical to every other second. Time appeared to be the one thing everyone shared equally. Then, just over a century ago, a quiet revolution changed everything. It didn't begin with an enormous telescope, or a giant rocket, or an astonishing discovery somewhere among the stars. It began with a simple thought. What if time itself wasn't fixed? What if it could move differently depending on where you were, or how fast you traveled? The answer would forever change physics. It would explain mysteries hidden inside gravity. It would help us understand black holes. It would eventually allow technologies like GPS satellites to guide millions of people every day. Without correcting for tiny differences in the flow of time, your phone could slowly become inaccurate by miles. The universe isn't merely strange in distant galaxies. Its strange behavior quietly influences your daily life, even though you never notice it. That may be the most beautiful part of this story. Some of the greatest mysteries in the cosmos aren't hidden because they're far away. They're hidden because they're happening so gently that we pass through them every single day without realizing. Every sunrise, every heartbeat, every passing second. Time quietly carries us forward, yet it doesn't carry everyone equally. Somewhere near a giant planet, it flows just a little differently. Near an incredibly dense neutron star, it slows more dramatically. Near the edge of a black hole, it can almost seem to pause altogether. The universe has no master clock keeping perfect rhythm for everything that exists. Instead, every corner of space keeps its own quiet measure of time. Tonight, we'll leave behind the familiar clocks hanging on our walls. We'll journey to places where gravity reshapes the passage of seconds. We'll visit worlds where years feel strangely unfamiliar. We'll drift near stars so dense that time itself begins to lose its ordinary meaning. We'll discover why astronauts age just a tiny fraction differently than the rest of us. And we'll explore one of the most astonishing ideas ever revealed by science. That time was never the perfectly straight road we imagined. Instead, it is a vast, invisible landscape, one with gentle hills, deep valleys, slow rivers, and quiet currents that have been flowing through the universe since the very beginning. So settle in, take a slow, comfortable breath, allow the noise of the day to drift away. Because tonight, we aren't simply exploring distant worlds, we're exploring the hidden places, where time itself chooses a different path. 2. The invisible oceans floating through space. Have you ever imagined standing on the shore of the largest ocean that has ever existed? Not the Pacific, not the Atlantic, not even all of Earth's oceans combined. Imagine an ocean so immense that our entire planet would disappear inside it without leaving the faintest ripple. Now imagine something even stranger. There are no waves, no beaches, no salt carried by the wind, no sound of water meeting the shore, because this ocean has no shoreline at all. It drifts silently through the darkness of space, hidden between the stars, invisible to human eyes. It sounds impossible. After all, space is supposed to be empty. That is one of the very first ideas most of us learn about the universe. Planets are separated by enormous stretches of nothing. Stars float alone in vast darkness. Galaxies drift through nearly empty space. But nature has a habit of hiding extraordinary things inside places that appear completely ordinary. The emptiness between the stars is not truly empty. It never has been. If you could somehow shrink yourself until individual molecules became visible, you would discover that space is filled with an astonishing variety of invisible travelers, tiny grains of dust, frozen crystals, clouds of hydrogen, delicate traces of carbon, molecules drifting so slowly that they may wander for millions of years before encountering anything else. And among these silent travelers, one molecule appears again and again: water. not rivers. Not lakes, not clouds like those floating above Earth, but countless individual water molecules quietly suspended throughout the galaxy. They are so thinly spread that you could pass through an entire cloud without realizing it. Yet together, they form reservoirs beyond imagination. For centuries, people believed Earth might be unique because of its oceans. Water seemed almost miraculous. It carved mountains, fed forests, filled rivers, allowed every known living thing to survive. It became so familiar that we sometimes forget just how unusual it truly is. Two tiny hydrogen atoms, one oxygen atom. Together, they create one of the most remarkable substances in the universe. Liquid water shapes landscapes. Ice floats instead of sinking. It stores heat with extraordinary efficiency. Without these unusual properties, Earth would be a very different world, perhaps one completely unable to support life. So naturally, scientists once assumed water must be relatively rare. Then telescopes became more powerful. Radio observatories began listening to the quiet whispers of molecules drifting through deep space. Infrared instruments started seeing what human eyes never could. Slowly, an astonishing picture began to emerge. Water was almost everywhere, hidden inside cold molecular clouds, frozen within comets, locked beneath the icy crusts of distant moons, wrapped around newborn stars, even drifting freely between entire solar systems. The universe, it seemed, had been quietly carrying water all along. One of the most surprising discoveries came from enormous clouds floating near regions where stars are born. These clouds appear completely black to ordinary telescopes. Yet inside them, chemistry is quietly taking place. Atoms gently collide, tiny ice particles gather. Simple molecules slowly become more complex. It is here, inside these cold nurseries of the cosmos, that water begins one of its longest journeys. Sometimes it freezes onto microscopic grains of dust. Sometimes ultraviolet light breaks it apart. Sometimes new molecules form again only moments later. The cycle continues endlessly, patiently, silently, over millions of years. In a sense, every drop of water on Earth may have experienced an incredible voyage before our planet even existed. Long before dinosaurs walked beneath ancient forests, long before the first oceans formed, long before Earth itself had taken shape. Some of the water we drink today may have drifted through interstellar space for billions of years, passing dying stars, crossing entire spiral arms of the Milky Way, waiting quietly until gravity gathered it into the cloud that would eventually become our solar system. When you pour yourself a simple glass of water, you may be holding something older than the sun. That thought has a gentle kind of beauty. Every sip carries an unimaginably ancient history, a story stretching across nearly the entire lifetime of the universe. And yet, as extraordinary as that sounds, it becomes even more astonishing. Astronomers have discovered places where water exists on scales almost impossible to comprehend. In one distant region, surrounding an active supermassive black hole, scientists detected an enormous cloud of water vapor. Its distance from Earth is measured not in thousands or even millions, but billions of light years. The cloud itself is staggering. It contains enough water to fill Earth's oceans trillions upon trillions of times over. Trying to picture such a number is almost impossible. Imagine every ocean, every lake, every river, every glacier, every raindrop that has ever fallen onto our world. Now multiply all of that by numbers so large they lose ordinary meaning. The result is still only a tiny glimpse of what the universe can create. Of course, this is not an ocean anyone could ever sail. The water exists mostly as vapor spread across an unimaginably vast region of space. The molecules are incredibly far apart. If you floated through it wearing an ordinary spacesuit, you wouldn't feel surrounded by water at all. You would simply drift through darkness. The ocean would remain completely invisible. That may be one of the universe's favorite tricks. Its greatest treasures often refuse to reveal themselves to our eyes. The brightest stars are not always the most interesting. The largest structures are frequently invisible. The oldest travelers leave almost no trace. And some of the greatest oceans ever discovered cannot produce a single wave. Tonight, as you continue this quiet journey across the cosmos, perhaps it's comforting to remember that space is not an empty wilderness after all. It is filled with gentle currents, invisible chemistry, ancient molecules wandering patiently through the darkness. Some are waiting to become clouds. Some will become comets. Some may one day fall as rain onto worlds that have not even formed yet. And somewhere, drifting peacefully between distant stars, enormous invisible oceans continue their silent voyage, never crashing against a shore, never reflecting the light of a nearby sunset, simply waiting, molecule by molecule, beneath the endless night of the universe. 3. The quiet life of sleeping galaxies. Not every galaxy in the universe is bursting with brilliant new stars. Some have already lived through their brightest days. Their great seasons of creation have quietly come to an end, and now they drift through the cosmos in remarkable silence, no longer building the dazzling stellar nurseries that once filled them with light. Astronomers sometimes describe these places as sleeping galaxies. It is a beautiful phrase. Not because these galaxies are truly asleep, of course. Galaxies don't close their eyes. They don't dream. They don't rest in the way living creatures do. But from a distance, they almost seem to. Their busy youth has faded into a calm and peaceful old age. The brilliant fireworks have ended. The quiet has remained. Imagine walking through an ancient city long after everyone has gone home. The streets are still there. The buildings still stand. The lamps continue glowing softly. But the laughter has disappeared. The marketplaces are empty. Nothing new is being built. The city is alive, yet somehow deeply quiet. That is what many sleeping galaxies are like. They still contain billions of stars. Some contain hundreds of billions. Their graceful spiral arms or smooth elliptical shapes continue drifting through space exactly as they have for countless millions of years. But inside them, something profound has changed. The birthplaces of stars have fallen silent. To understand why this matters, we first have to remember something remarkable. Stars are not permanent. Every star you see in the night sky had a beginning. Long before it became a shining sun, it was simply part of an enormous cloud of cold gas and microscopic dust. Over immense stretches of time, gravity gently gathered that material together. The cloud slowly collapsed. It became denser, hotter, brighter, until one extraordinary moment arrived. Deep inside its growing heart, hydrogen atoms began to fuse together. A new star was born. Across the universe, this quiet process has repeated itself for more than 13 billion years. Again, and again, and again. Some galaxies became magnificent stellar factories. They transformed enormous reservoirs of hydrogen into countless generations of stars. Young blue giants, warm yellow suns, tiny red dwarfs destined to shine for trillions of years. Entire families of stars were born together inside glowing nebulae that stretched across hundreds of light years. These newborn stars illuminated their surroundings like scattered lanterns. Their light carved beautiful shapes into nearby clouds. They warmed young planets. They forged the heavier elements that would eventually become mountains, oceans, and perhaps even life itself. In many ways, galaxies are giant gardens. Their flowers are stars, and for billions of years, they bloomed continuously. But even the richest garden cannot bloom forever if no new seeds remain. Eventually, many galaxies begin running low on the one ingredient they need most: cold hydrogen gas. Without it, star formation slows, then slows even more. Eventually, it almost stops. The galaxy itself still exists. Its countless older stars continue shining faithfully. Some are only a few billion years old. Others were born when the universe itself was still very young. Together, they continue orbiting the galaxy's center in slow, graceful paths that may take hundreds of millions of years to complete a single revolution. From far away, the galaxy still appears magnificent. Its beauty has not disappeared. It has simply changed. Its brilliant blue glow gradually softens. Blue stars live fast and die young. They burn through their fuel quickly before ending their lives in spectacular explosions. Without new blue stars replacing them, something subtle begins to happen. Older stars slowly take over the galaxy's appearance. Cooler stars, redder stars, gentler stars. The entire galaxy gradually changes color. It becomes warmer, softer, almost golden, like autumn leaves replacing the bright greens of spring. Astronomers can often estimate a galaxy's age simply by observing its color. Blue usually whispers of youth. Red often speaks of quiet age. It is one of the universe's most peaceful transformations. Nothing dramatic happens overnight. No great catastrophe announces the change. The galaxy simply grows older, just as forests slowly mature, just as mountains slowly erode, just as rivers quietly reshape the land over countless generations. The universe seems remarkably patient with growing old. Sometimes, however, galaxies fall asleep for reasons even more surprising. At the center of almost every large galaxy lies a supermassive black hole. Most spend much of their existence peacefully resting. But every so often, enormous amounts of gas fall toward them. As the gas spirals inward, it becomes unimaginably hot. It releases staggering amounts of energy. Ironically, this brilliant activity can prevent new stars from forming. Powerful jets and fierce radiation sweep away the very gas that would otherwise collapse into stellar nurseries. The galaxy's own central giant may gently extinguish its future generations of stars, not by destroying the stars already there, but by preventing new ones from ever being born. It is one of the universe's quiet paradoxes. The brightest object inside the galaxy may slowly bring an end to the galaxy's brightest era. Galaxies can also lose their ability to create stars when they wander too close to enormous galaxy clusters. As they travel through these crowded regions, invisible hot gas filling the cluster can slowly strip away their own precious hydrogen. Little by little, the raw material for future stars disappears. The galaxy continues its journey, but its future grows quieter. Astronomers have even discovered galaxies that appear to have stopped forming stars astonishingly early in cosmic history. Some became quiet when the universe itself was still very young. Why this happened remains one of astronomy's fascinating mysteries. Perhaps they consumed their fuel extraordinarily quickly. Perhaps violent encounters with neighboring galaxies altered their fate. Or perhaps their central black holes became active at just the wrong moment. The answer is still unfolding. The universe rarely gives away all of its secrets at once. Yet, there is something deeply comforting about these sleeping galaxies. Our own Milky Way is still awake. Even now, new stars continue to emerge inside vast molecular clouds scattered across its spiral arms. Somewhere, at this very moment, gentle clouds of hydrogen are collapsing. Tiny newborn stars are opening their brilliant eyes for the very first time. Future planets may already be gathering around them. Future oceans, future skies, perhaps even future civilizations. Creation continues. But one day, billions upon billions of years from now, our own galaxy will begin changing as well. The pace of star birth will gradually slow. The great stellar nurseries will become fewer. The brilliant blue stars will become increasingly rare. The Milky Way, too, may eventually enter its own peaceful old age. Not with violence, not with catastrophe, but with remarkable quietness. its countless older stars will continue shining faithfully across the darkness. They will illuminate planets that remain. They will orbit the galactic center, just as they always have. Only the soundless rhythm of creation will slowly fade. Perhaps there is something unexpectedly beautiful about that thought. The universe is not always rushing forward. Sometimes it knows how to become still. Sometimes even galaxies, among the largest structures ever created, seem content to simply drift beneath the endless stars, carrying the light of ancient suns that have faithfully illuminated the darkness for billions of years. And perhaps, in their extraordinary silence, they remind us that not every ending needs to arrive with noise. Some endings arrive gently, like evening becoming night, like autumn becoming winter, or like a galaxy quietly falling asleep beneath the endless universe. 4. The slowest events in the universe. Some cosmic events happen so slowly that an entire human civilization could rise and disappear before they even finish. When we think about the universe, we usually imagine things happening with breathtaking speed. A star explodes in a brilliant flash. A comet streaks across the night sky. A meteor blazes through Earth's atmosphere for only a few unforgettable seconds. Even light, the fastest thing we know, races across space at nearly 300,000 kilometers every second. The universe often feels energetic, dynamic, always in motion. But what if some of its greatest stories unfold so slowly that no human being could ever witness them from beginning to end? Imagine planting a tiny seed. Now, imagine knowing that the tree it becomes will not reach full height for 10,000 years. You would never see its tallest branches. Neither would your children, nor the countless generations that follow. Yet, compared to some events in the universe, even that tree would seem to grow remarkably quickly. Out among the stars, there are changes so patient that entire civilizations could appear, flourish, vanish, and be forgotten before those changes advance by even a single noticeable step. The pyramids of Egypt are often described as ancient. They have stood for more than 4,000 years. The Roman Empire rose and fell. Languages were born. Continents were explored. Entire cultures transformed the world. And yet, from the perspective of many cosmic events, all of human history is little more than a single heartbeat. The universe keeps time differently, not because it is in a hurry, but because it has never needed to rush. If you could somehow watch the cosmos from outside time itself, millions of years might drift past as gently as clouds crossing a quiet afternoon sky. Galaxies would slowly rotate. Stars would gradually migrate through invisible rivers of gravity. Nebulae would bloom almost like flowers opening in extreme slow motion. Nothing would seem dramatic. Everything would simply unfold, patiently, calmly, as though the universe has mastered an art that humanity often struggles to practice, the art of waiting. Perhaps nowhere is this more beautifully demonstrated than inside giant molecular clouds. These enormous clouds of hydrogen and dust are the birthplaces of stars. Some stretch across hundreds of light years. At first glance, they appear almost motionless, and in many ways, they are. Gravity is quietly pulling the cloud inward. Tiny regions slowly become denser. Cold gas gathers almost imperceptibly. But this process unfolds over millions of years. If a person could somehow watch continuously, day after day, nothing would seem to happen. 1,000 years would pass, still almost nothing. 10,000 years, still no obvious change. Even after an entire civilization had come and gone, the cloud would appear almost exactly the same. Only after millions of years would its hidden work finally become visible. A new star would quietly ignite, not with sudden violence, but with extraordinary patience. The same is true for galaxies themselves. Our own Milky Way completes one full rotation roughly every 230 million years. That number is almost impossible to imagine. The dinosaurs appeared and disappeared during only part of a single galactic year. Every human who has ever lived existed during less than one tiny fraction of one orbit around the center of our galaxy. The Sun has circled the Milky Way only about 20 times since it first formed, 20 journeys across 4.5 billion years. When viewed this way, even our ancient solar system begins to feel surprisingly young. Then there are the stars. Many of them burn for billions, or even trillions of years. The smallest red dwarf stars are particularly remarkable. Unlike massive blue stars that race through their fuel in only a few million years, red dwarfs consume their hydrogen with astonishing care. They burn slowly, gently, almost reluctantly. Some are expected to shine for 10 trillion years. That is nearly 1,000 times longer than the current age of the universe. In fact, something rather extraordinary follows from this. The universe is simply not old enough for a single red dwarf to have reached the end of its natural life. Not one. Every red dwarf that has ever been born is still shining today. The universe has never witnessed one grow old naturally. It is a curious thought. Some of the longest stories in existence have not yet reached their final chapter. We arrived too early. Far too early. Even mountains in space possess remarkable patience. On Earth, mountains are constantly reshaped by wind, rain, rivers, and shifting tectonic plates. But many mountains on distant worlds barely change at all. Olympus Mons on Mars, the largest volcano in the solar system, has stood quietly for immense spans of time. Without flowing water or active plate tectonics constantly wearing it away, it remains astonishingly well preserved. Its slow story continues almost undisturbed beneath the thin Martian sky. Elsewhere, entire planetary surfaces evolve at glacial speeds. Tiny impacts, microscopic erosion from solar radiation, the occasional passing comet, changes measured not in years, but in millions. Even black holes, often imagined as violent monsters of the universe, reveal surprising patience. A black hole can slowly consume surrounding gas for billions of years. If left completely alone, it can survive for timescales so enormous that ordinary numbers begin to lose meaning. According to current theories, the largest black holes may not completely disappear through Hawking radiation until after unimaginable spans of time. Far longer than every star currently shining will continue to exist. By then, the universe itself may be almost unrecognizable. And still, the black hole would continue its incredibly slow farewell. Perhaps this is one of the universe's gentlest lessons. Not everything meaningful happens quickly. Some of the greatest transformations are almost invisible while they are taking place. A galaxy quietly changes color over billions of years. A cloud patiently becomes a star. A planet slowly cools. An orbit gradually shifts. Gravity performs its work without ever raising its voice. Human life often feels filled with deadlines. Hours, days, years. We become impatient when a website takes a few extra seconds to load. We wonder why seasons seem long. We wish certain moments would arrive sooner. Yet beyond our little world, the universe has never measured success by speed. It creates with extraordinary patience. It shapes with remarkable gentleness. Its greatest masterpieces are often the result of waiting longer than human imagination can comfortably comprehend. Perhaps that is why looking toward the stars feels strangely calming. The universe reminds us that existence is not a race. Some things are meant to happen quickly. Others require millions of years before revealing their quiet beauty. And somewhere, even now, an invisible cloud is slowly becoming a future sun. A distant galaxy is completing another tiny fraction of its graceful rotation. A red dwarf continues burning with almost unimaginable patience. Events so slow that humanity may never notice them. Yet, they are happening all around us. Every moment, every second, every age. silently continuing their timeless journey through the endless universe. 5. The cosmic shadows that nobody can see. Some of the largest objects in the universe are completely invisible, and yet their gravity quietly shapes everything around them. When you look up at the night sky, it is easy to believe that the universe is made of light. Stars sparkle like scattered diamonds. Galaxies glow softly across unimaginable distances. Nebulae bloom with delicate colors that stretch across hundreds of light years. Even the faintest objects we discover usually reveal themselves by emitting, reflecting, or blocking light. For thousands of years, this seemed perfectly reasonable. If something existed, surely we could see it. And if we couldn't see it, perhaps it simply wasn't there. But the universe has a wonderfully gentle way of reminding us that our eyes tell only part of the story. Imagine walking through a quiet forest just before sunrise. The trees stand perfectly still. The air is calm. You hear no footsteps, you see no movement. Yet every so often, a branch bends, leaves begin to rustle, tall grass slowly parts, as though something unseen has quietly passed through. You never glimpse the traveler itself, only its influence, only the delicate changes it leaves behind. Astronomers have experienced something remarkably similar. For nearly a century, they have been watching the universe carefully. Again and again, they have noticed stars moving in unexpected ways, galaxies spinning faster than they should, clusters of galaxies holding together when, by all ordinary calculations, they ought to drift apart. Something invisible appears to be gently pulling on everything around it. Something enormous, something silent, something that has never reflected a single ray of light. Today, scientists call this mysterious substance dark matter. The name sounds dramatic, almost mysterious. Yet in many ways, it simply describes our uncertainty. It is dark, not because it is black like charcoal or hidden in shadow. It is dark because it does not interact with light the way ordinary matter does. Light passes by as though nothing were there. No reflection, no glow, no color, no visible surface. If Earth somehow drifted through a cloud of dark matter tomorrow, you would not see it. You would not smell it. You would not hear it. Your eyes would remain completely unaware of its presence. And yet, its gravity would still be there, quietly, patiently, just as gravity has always worked. It is one of the strangest ideas ever proposed. The largest structures in the universe may be built upon something completely invisible. Imagine constructing an enormous cathedral. Its towers rise toward the sky. Its windows sparkle in the afternoon sun. Visitors admire its beauty for centuries. But hidden beneath everything lies a vast foundation buried deep underground. No one ever sees it. Yet without it, the entire building would collapse. Dark matter may play a similar role throughout the cosmos. Galaxies appear to rest inside gigantic halos of invisible mass, like unseen scaffolding supporting brilliant cities of stars. Without these halos, many galaxies would simply spin themselves apart. This realization came gradually. In the early 20th century, astronomers carefully measured how quickly stars orbited the centers of galaxies. According to the gravity produced by the visible stars alone, the outer regions should have moved much more slowly. Instead, they raced around at astonishing speeds. It was as though the galaxy contained far more mass than anyone could see. At first, many assumed their calculations must be wrong. Perhaps telescopes had missed faint stars. Perhaps enormous clouds of cold gas remained hidden. Perhaps the measurements themselves contained tiny errors. Years passed, then decades. Better telescopes arrived. Sharper observations followed. Yet the mystery only grew stronger. Every new measurement whispered the same quiet message. There is more here than meets the eye. Eventually, astronomers reached a remarkable conclusion. Everything we can see, every star, every planet, every moon, Every cloud, every asteroid, every living creature, every grain of sand on Earth makes up only a small fraction of the universe's total matter. The rest remains invisible. That thought is difficult to absorb. Imagine opening an enormous book containing 1,000 pages. Now imagine discovering that everything humanity has ever directly observed fills only about 150 of those pages. The remaining hundreds describe something we still cannot read. We know the pages exist. We can measure their weight. We can see them affecting the story. But their words remain hidden. Perhaps the most beautiful evidence for dark matter comes not from galaxies themselves, but from light. Light usually travels in straight lines, yet Einstein showed us that gravity bends space itself. As a result, light passing near massive objects follows gentle curves instead of perfectly straight paths. Astronomers call this gravitational lensing. Sometimes a distant galaxy appears stretched into glowing arcs. Sometimes it splits into multiple images. Sometimes its light becomes subtly distorted. By carefully studying these delicate patterns, scientists can calculate how much gravity lies between us and those distant galaxies. Again and again, the answer surprises them. There is far more gravity present than visible matter can explain. The invisible leaves fingerprints upon the light. Not by shining, but by quietly bending the paths of photons crossing billions of light years. It is almost like watching the wind. You never actually see the wind itself. You only notice branches swaying, clouds drifting, grass gently bending. The wind reveals itself through movement. Dark matter reveals itself in much the same way. Not through light, but through gravity. Some of the largest shadows in the universe are not really shadows at all. They are enormous invisible halos surrounding galaxies, stretching far beyond the stars we can see. Our own Milky Way is believed to float inside one of these gigantic structures. Its visible spiral arms are only the bright heart of something vastly larger. Far beyond the last familiar stars, far beyond the glowing gas clouds, an immense invisible halo quietly extends into space. If somehow your eyes could suddenly perceive dark matter, the night sky might transform completely. Galaxies would no longer appear as isolated islands of light. Instead, each would be wrapped inside an enormous ghostly cloud many times larger than the galaxy itself. The universe would look fuller, richer, almost woven together by invisible threads. Yet for all we have learned, the mystery remains. No one knows exactly what dark matter is. It does not seem to be made of atoms. It is not ordinary gas. It is not frozen planets hiding in darkness. It is something entirely different. Physicists around the world continue searching. Powerful underground detectors wait patiently for tiny interactions. Space telescopes map its invisible influence across the cosmos. Particle accelerators attempt to recreate conditions from the earliest moments after the universe began. So far, the universe has remained wonderfully quiet. It has not yet revealed the answer. Perhaps that is fitting. Not every mystery wishes to be solved quickly. Some seem content simply to accompany us, encouraging each new generation to ask another question, to build another telescope, to imagine another possibility. And perhaps, as you gaze at the stars tonight, there is something strangely comforting about knowing that the visible universe is only part of the story. Beyond every shining galaxy, beyond every glowing nebula, beyond every brilliant star, there are silent companions that no human eye has ever seen. Invisible giants, patient architects, cosmic shadows that never block the light, yet quietly shape the universe, one gentle pull at a time. 6. The worlds that never saw a sunrise. Imagine living on a world where the sun never rises, not because it's night, but because no star has ever shined above you. Every morning on Earth begins with a familiar miracle. Long before most of us open our eyes, sunlight is already making its quiet return. The darkness softens. The horizon slowly brightens. Shadows begin to fade as the sun climbs gently above the landscape, painting clouds with delicate shades of gold and orange. It has happened every day for billions of years, so faithfully that we rarely stop to appreciate it. Sunrise feels permanent, almost guaranteed. It marks the beginning of our days, the changing of the seasons, the rhythm by which nearly every living thing on Earth has learned to exist. Plants stretch toward it. Birds greet it with song. Even our own bodies carry ancient biological clocks that quietly anticipate its arrival each morning. We often think of sunrise as one of nature's universal experiences. Surely, every world with a sky must know the feeling of watching its star appear over the horizon. But the universe, as it so often does, has a gentler and stranger story to tell. There are worlds where the sun never rises. Not because the night is unusually long, not because clouds permanently cover the sky, but because no sunrise has ever existed there. Not yesterday, not millions of years ago, not even once since the world itself was born. Imagine standing on such a planet. Above you stretches an endless black sky, not the soft darkness we know after sunset, where distant stars sparkle gently overhead. This darkness is different, deeper, colder, the kind of darkness that has never been interrupted by dawn. You wait. Surely sooner or later, a faint glow must appear along the horizon. Perhaps just a thin line of light. Perhaps a distant sunrise is taking its time. Hours pass. Nothing changes. Days become weeks. Weeks become years. The horizon remains exactly as it was. No golden morning, no bright afternoon, no evening twilight. Simply endless night. At first, this sounds almost impossible. How could a planet exist without a sun? After all, planets are born around stars. Gravity gathers gas and dust into enormous spinning disks. Stars ignite at their centers. Planets gradually assemble from the remaining material. That is how our own solar system came into existence more than 4.5 billion years ago. For a long time, astronomers assumed this was simply how every planetary system must work. Then, in the final years of the 20th century, something unexpected happened. Telescopes began finding planets where no star could be seen. At first, many scientists questioned the observations. Perhaps the star was simply too faint. Perhaps it was hidden behind dust. Perhaps the measurements were mistaken. But the evidence continued to grow. Again and again, astronomers discovered lonely planets drifting through interstellar space entirely on their own. These extraordinary objects are often called rogue planets. The name sounds adventurous, almost rebellious, as though they deliberately escaped from their home systems. In reality, their stories are probably much quieter. Many likely formed around ordinary stars, just as Earth did. But early in their histories, something dramatic happened. Perhaps a giant neighboring planet pulled them away through countless gravitational encounters. Perhaps two stars passed dangerously close together, disturbing the delicate balance of an entire planetary system. Perhaps their own young solar systems became crowded and unstable, sending one unfortunate world drifting into the darkness forever. Like leaves carried away by an invisible current, these planets quietly slipped free from the stars that once illuminated them. And then, they simply kept going. Across millions of years, across billions of kilometers. Eventually, many entered the enormous spaces between stars themselves. There, distances become almost impossible to imagine. The nearest star may lie several light years away. Its light becomes little more than another bright point among countless others. From the surface of a rogue planet, there is no dominant sun, no warm disk crossing the sky, only distant stars scattered evenly across an eternal night. If someone stood upon such a world, they would never witness dawn. Not because they were unlucky, but because dawn does not exist there. Yet surprisingly, complete darkness does not necessarily mean complete lifelessness. This is one of the most fascinating discoveries modern astronomy has suggested. Some rogue planets may continue producing heat long after losing their parent stars. Deep inside their rocky interiors, radioactive elements slowly decay. The process is incredibly gentle, releasing tiny amounts of warmth over billions of years. On Earth, this hidden heat helps drive volcanoes, earthquakes, and the slow movement of continents. On an isolated rogue planet, the same invisible energy might continue warming the interior long after sunlight has disappeared forever. If such a planet were large enough, something remarkable could happen. A thick atmosphere might trap that internal heat, almost like an enormous blanket wrapped around the planet. Far beneath frozen clouds, liquid water could potentially survive. Not because of sunlight, but because the planet quietly warms itself from within. Imagine an underground ocean hidden beneath kilometers of ancient ice. No waves reflecting sunlight, no sparkling beaches, no blue sky overhead. Only warm, silent water enclosed within darkness. It sounds unfamiliar. Yet we already know of places not entirely unlike this much closer to home. Several icy moons in our own solar system, including Europa and Enceladus, hide enormous oceans beneath frozen crusts. Their surfaces receive only faint sunlight, yet tidal forces generated by giant planets continue heating their interiors. Life, if it exists there, would never know an ordinary sunrise either. Instead, it might gather around warm hydrothermal vents, just as many organisms do deep within Earth's oceans today. On our own planet, sunlight powers most ecosystems, but not all of them. Far below the deepest waves, where sunlight has never reached, entire communities thrive around volcanic vents. Tiny microbes draw energy not from light, but from chemistry itself. Giant tube worms, strange shrimp, countless unseen organisms. Their world has no dawn, no sunset, no changing seasons. And yet, life continues, quietly, patiently. Perhaps the universe has been teaching us something all along. Maybe sunlight, wonderful as it is not the only path toward warmth, not the only path toward possibility. Astronomers now estimate that rogue planets may be astonishingly common. Some studies even suggest they could outnumber the stars themselves. Imagine that for a moment. For every brilliant sun shining across the galaxy, there may be one, or perhaps many, silent worlds wandering alone through the darkness, each carrying its own long history, its own mountains, its own frozen valleys, its own hidden oceans, perhaps even its own quiet mysteries. They travel without sunrise, without sunset, without a familiar home in the sky. Only gravity gently guides their endless journeys around the center of the Milky Way. Ironically, these lonely worlds may also become some of the longest-lived homes in the universe. Long after ordinary stars begin exhausting their fuel, long after brilliant blue suns disappear, the rogue planets will still drift onward, patient, silent, unhurried, never waiting for a sunrise that will never come. And perhaps there is something unexpectedly peaceful about that image. A world does not always need a brilliant morning sky to have a story worth telling. Some journeys unfold beneath endless daylight, others unfold beneath endless night, yet both remain part of the same extraordinary universe. A universe vast enough to create places where morning has never arrived, and where the stars themselves are nothing more than distant memories scattered across an eternal sky. 7. The ancient light still traveling toward Earth. Some of the light reaching your eyes tonight began its journey before Earth even had dinosaurs. If you're enjoying these peaceful stories from across space, subscribing helps us continue sharing one sleepy mystery at a time. Tonight, before you close your eyes, step outside for just a moment. Look up. The stars seem so close, almost familiar. Some shine brightly enough to catch your attention immediately. Others are so faint that you notice them only after your eyes have adjusted to the darkness. Together, they create the comforting illusion that the universe is unfolding before you in real time. That what you see is happening now, but the night sky has one final secret to whisper. Nothing you see is truly happening in this moment. Every single beam of starlight reaching your eyes tonight is carrying a message from the past. For the nearest stars, that message may be only a few years old. For others, it has traveled hundreds, thousands, or even millions of years before finally arriving here. Light, despite being the fastest traveler in the universe, is not infinitely fast. It moves at an astonishing speed, about 300,000 kilometers every second, fast enough to circle Earth more than 7 times in a single heartbeat, fast enough to reach the moon in just over 1 second, fast enough to cross the vast distance between Earth and the Sun in about 8 minutes. Yet the universe is so unimaginably enormous that even light must practice extraordinary patience. Distances between stars are measured not in kilometers, but in light years. A light year is not a measure of time. It is a measure of distance. It describes how far light can travel in one entire year. Nearly 10 trillion kilometers. When astronomers say a star is 100 light years away, they are quietly telling us something remarkable. The light entering your eyes tonight left that star 100 years ago, before the invention of television, before the first commercial airplanes filled the skies, before countless people alive today had even been born. You are seeing history. The universe is allowing you to look backward through time, and as your gaze travels farther into space, your view travels farther into the past. This idea becomes even more astonishing when we look beyond our own neighborhood of stars. Many galaxies visible through modern telescopes are millions of light years away. Their light began its journey long before our earliest human ancestors learned to make stone tools. Some galaxies appear as they existed before modern humans walked across Africa. Others reveal an even older universe. Their ancient light departed before mammals became the dominant animals on Earth. Long before forests covered familiar continents. Long before the great dinosaurs disappeared beneath the shadow of the asteroid that forever changed our planet's history. Imagine that for a moment. Some of the light quietly entering your eyes tonight began traveling across the universe before a single Tyrannosaurus Rex ever took its first step. It crossed unimaginable distances while continents drifted, mountains rose, oceans opened, species appeared and vanished, civilizations emerged. Entire chapters of Earth's history unfolded beneath its silent journey. Only now, after millions of years, has that tiny beam finally reached your eyes. In a very real sense, every clear night transforms Earth into a natural time machine, not one built from gears or complicated machines, but one created simply by looking upward. Astronomers rarely observe the universe as it exists today. Instead, they assemble countless pieces of its long history. Nearby stars reveal recent chapters. Distant galaxies reveal ancient ones. The farther we look, the younger the universe becomes. Eventually, powerful telescopes allow us to see galaxies whose light has traveled for more than 13 billion years. These delicate points of light began their journeys when the universe itself was still remarkably young. The stars inside them were among the earliest generations ever formed. Some of those galaxies no longer exist as we see them. Over billions of years, they have collided with neighbors, changed shape, created countless new stars, perhaps even disappeared entirely. Yet, their ancient light continues traveling faithfully through space, preserving a picture of a universe long gone. Light, in many ways, becomes the universe's greatest historian. It remembers everything, every star that ever shined, every galaxy that ever glowed, every supernova that briefly illuminated the darkness before fading forever. Their stories remain written inside streams of photons racing endlessly through space. Most will never encounter anything at all. They simply continue across the vast emptiness. Some drift for billions of years without striking a single atom. Others eventually meet tiny grains of cosmic dust. Some disappear into black holes, never escaping again. And an unimaginably small number arrive somewhere extraordinary. A small blue planet orbiting an ordinary yellow star, where curious creatures have learned to build telescopes and wonder. Perhaps the most beautiful part of this story is how incredibly unlikely every observation truly is. Consider one single photon. It leaves a distant galaxy more than 60 million years ago. At that moment, giant dinosaurs still roam ancient forests on Earth. The Atlantic Ocean is narrower than it is today. Flowering plants continue spreading across the continents. That photon begins an uninterrupted journey. Second after second, year after year, century after century. It never stops, it never slows. Entire mountain ranges rise while it travels. Ice ages come and go. Human beings evolve. Agriculture begins. Empires rise and fall. Languages appear. Books are written. Music is composed. Cities glow beneath electric lights. Still, the photon continues. Then one quiet evening, after traveling farther than almost any human mind can truly imagine, it enters Earth's atmosphere. It slips between drifting molecules of air, passes unnoticed through the darkness, reaches a telescope, reflects from a carefully polished mirror, and finally comes to rest inside someone's eye. Its incredible journey ends in a single instant of observation. A journey lasting tens of millions of years, completed by the blink of an eye. Every photograph captured by an observatory is therefore much more than a beautiful image. It is a collection of ancient arrivals. Each tiny point of light has its own history, its own departure, its own extraordinary voyage across time. Together they become a portrait not simply of space, but of the universe remembering itself. Sometimes people wonder whether the night sky we admire still exists exactly as we see it. The honest answer is, not entirely. Some stars have already changed, some have grown brighter, others have quietly faded. A few may even have exploded long ago. Their final light is still crossing the darkness toward us. One day, perhaps centuries or millennia from now, future observers on Earth will witness an explosion that actually happened long before they were born. The universe does not deliver its news immediately. It whispers slowly, patiently, across unimaginable distances. Perhaps that is why the night sky feels so timeless. When we look upward, we are never seeing one single moment. We are seeing countless moments woven together. Some are only a few years old. Others began before the first humans ever looked toward the stars. Some started traveling before Earth had forests. Others before Earth had dinosaurs. Every glance into the heavens becomes a quiet conversation with the past. A reminder that light is more than illumination. It is memory. It is history carried across impossible distances. And every clear night, without asking anything in return, the universe gently shares another page from its oldest diary. If you're enjoying these peaceful stories from across space, subscribing helps us continue sharing one sleepy mystery at a time. 8. The quietest places in the cosmos. There are places in the universe so empty that millions of light years can pass without finding another galaxy. When most of us imagine the universe, we picture it overflowing with stars, brilliant galaxies stretching across the darkness, colorful nebulae glowing like enormous celestial paintings, clusters of galaxies gathered together by gravity, each containing hundreds or even thousands of their own shining worlds. The universe seems wonderfully full, almost crowded. After all, every photograph taken by powerful telescopes appears packed with countless points of light. It is easy to believe that no matter where you traveled, there would always be another galaxy waiting somewhere beyond the horizon. But appearances can be wonderfully misleading. The universe has its bustling cities, its quiet suburbs, and then it has places so astonishingly empty that they almost defy imagination. Imagine standing in the middle of a vast desert, not one with distant mountains breaking the horizon, not one crossed occasionally by lonely roads. Instead, imagine a landscape so immense that you could travel for months without seeing another living thing, only endless silence. Now make that emptiness larger, far larger. Stretch it across millions of light years instead of miles. Replace grains of sand with nearly perfect darkness. Replace the empty sky with a sky that contains almost nothing at all. You begin to approach one of the quietest places the universe has ever created. Astronomers call these enormous regions cosmic voids. The name sounds almost poetic. A void. Not because absolutely nothing exists there. True emptiness may not exist anywhere in the universe. Even the darkest regions contain tiny traces of gas, wandering particles, invisible radiation, and the occasional lonely galaxy. But compared to the rich clusters surrounding them, cosmic voids are astonishingly empty. If the observable universe resembled a giant sponge, the bright galaxies would form the thin walls. The enormous holes between them would be the voids, invisible bubbles of extraordinary emptiness stretching across unimaginable distances. Some are tens of millions of light years wide. Others span hundreds of millions. Inside these vast regions, galaxies become incredibly rare. A traveler could journey for millions of light years before encountering another large galaxy. On human scales, that distance is impossible to comprehend. Our own Milky Way measures roughly 100,000 light years across. Light itself requires 100,000 years simply to cross our galaxy from one side to the other. Now imagine traveling not one galaxy wide, but 1,000 galaxies wide, without finding another major collection of stars. That is the quiet scale of a cosmic void. From inside such a place, the night sky would feel profoundly different. Here on Earth, even though city lights hide many stars, the heavens still appear beautifully alive. Thousands of nearby stars belong to our own galaxy. The pale ribbon of the Milky Way stretches gently across the darkness. Through powerful telescopes, countless distant galaxies quietly reveal themselves. The universe feels rich with company. But inside a great cosmic void, that familiar sense of abundance would slowly disappear. Nearby galaxies would become increasingly scarce. The brilliant rivers of distant galaxy clusters would lie unimaginably far away. Darkness would dominate every direction. The universe would feel less like a crowded city and more like standing alone in the middle of a frozen ocean beneath an endless winter sky. The remarkable thing is that these enormous empty regions were not deliberately created. They emerged naturally as the universe evolved. Shortly after the Big Bang, matter was distributed surprisingly evenly across space. Not perfectly evenly. Tiny differences already existed. Some regions contained just a little more matter. Others contained just a little less. At first, those differences were incredibly small, almost insignificant. Yet gravity is wonderfully patient. Regions containing slightly more matter slowly attracted additional material. They became denser, heavier, larger. Meanwhile, the slightly emptier regions gradually lost more and more of their matter to the growing structures nearby. Over billions of years, those tiny differences expanded into something magnificent. Galaxies gathered together into enormous filaments stretching across the cosmos. Galaxy clusters formed where these filaments intersected, and between them, the emptier regions became emptier still, like valleys deepening between rising mountains. Today, astronomers often describe the universe as a cosmic web. It is a beautiful image. Imagine an unimaginably enormous spider web, woven not from silk, but from galaxies themselves. Brilliant threads cross the darkness, great intersections glow with thousands of galaxies gathered together. Between those threads lie vast empty bubbles, the voids. Together, they create one of the largest structures known in nature. Ironically, these empty regions are essential for shaping everything around them. Without voids, there would be no cosmic web. Without emptiness, the rich architecture of the universe could never have emerged. Sometimes, the absence of something becomes just as important as its presence. Astronomers have discovered many remarkable voids. One of the most famous is the Boötes void, an enormous region roughly 300 million light-years across. When it was first carefully studied, scientists found astonishingly few galaxies inside such an enormous volume of space. Finding so little where they expected much more felt almost unsettling. It challenged their intuition. How could the universe produce emptiness on such unimaginable scales? Yet observation after observation confirmed the same quiet truth. The cosmos does not spread its galaxies evenly. It gathers them into graceful patterns, leaving extraordinary silence between. Interestingly, life inside a galaxy near the center of a great void might experience a very different view of the universe. The nearest neighboring galaxies would appear much farther away. The surrounding cosmos would seem less crowded. Future astronomers living there might even have developed different ideas about the large-scale structure of the universe before building sufficiently powerful telescopes. Their cosmic neighborhood would feel unusually isolated. In some ways, they might wonder whether they were alone among galaxies. Perhaps there is something unexpectedly comforting about these immense empty places. We often associate emptiness with loneliness, with absence, with silence. Yet silence is not always something to fear. A quiet forest allows us to hear birdsong. A calm lake reflects the stars more clearly than stormy water. The peaceful moments between musical notes often give a melody its beauty. Perhaps the universe understands this better than we do. Not every region needs to blaze with countless stars. Some places simply exist to create space. Room for galaxies to grow, room for gravity to weave its slow patterns, room for light to travel uninterrupted across hundreds of millions of years. Even a beam of ancient starlight, like the one we followed in our last journey, may spend much of its incredible voyage crossing these enormous silent regions. For millions of years, it encounters almost nothing at all. No planets, no stars, no galaxies, only darkness, only distance, only time, and yet it continues faithfully onward. Perhaps that patient beam of light has become the perfect traveler for such peaceful places, never hurried, never lonely, simply moving, second by second, across an ocean of remarkable stillness. Because even in the quietest places in the cosmos, where millions of light-years may pass without another galaxy appearing, the universe is never truly empty. It is simply resting, breathing slowly, leaving room for us to appreciate that sometimes the greatest wonder is not found in what fills the darkness, but in the extraordinary silence that surrounds it. 9. The objects that shouldn't exist. Astronomers have discovered objects so unusual that at first, many scientists believed they simply couldn't be real. The universe has always been remarkably good at surprising us. Every time humanity has believed it finally understood how the cosmos works, nature has quietly revealed another exception, another mystery, another impossible object waiting patiently to be discovered. It has happened throughout the history of astronomy. People once believed Earth was the center of everything. Then they discovered it wasn't. They believed the Milky Way was the entire universe. Then they learned it was only one galaxy among hundreds of billions. They believed planets belonged only to our own solar system. Today, we know of thousands orbiting distant stars. Again and again, the universe has gently reminded us that our imagination often reaches its limits long before reality does. Perhaps nowhere is this more beautifully demonstrated than by the extraordinary objects astronomers sometimes describe as impossible. Not because they truly violate the laws of physics, but because when they were first discovered, they seemed completely incompatible with everything scientists thought they knew. Imagine spending your entire life studying birds. You carefully document every species. You learn exactly how wings work. You understand how feathers generate lift. Then one quiet morning, someone shows you a bird with no feathers at all. Yet somehow it flies effortlessly across the sky. Your first instinct might not be excitement. It might be disbelief. Surely something must be wrong. Surely the observation is mistaken. Yet nature has no obligation to match our expectations. It simply continues being itself. The universe behaves in much the same way. Sometimes it creates things so unusual that the greatest challenge is not explaining them. It is believing they exist in the first place. One of the most famous examples appeared in the late 1960s. Astronomers using large radio telescopes detected an extraordinarily precise signal arriving from deep space. Unlike ordinary radio noise, this signal repeated with astonishing regularity. Every pulse arrived almost perfectly on time. Again, again, again. The precision was unlike anything ever observed. For a brief moment, some researchers jokingly wondered whether they had intercepted a message from an advanced civilization. The signal was even nicknamed Little Green Men 1. Of course, the explanation turned out to be something far more remarkable. The mysterious source was not an alien transmitter. It was the rapidly spinning remains of a dead star. Today, we call these extraordinary objects pulsars. Imagine a star much more massive than our Sun reaching the end of its life. After a spectacular supernova explosion, its core collapses under gravity with unimaginable force. Matter becomes compressed so intensely that a mass greater than our Sun is squeezed into a sphere only about 20 kilometers across, a city-sized object containing more mass than an entire star. Its magnetic fields become unbelievably powerful. Its rotation accelerates dramatically. Some pulsars spin hundreds of times every single second. As they rotate, beams of radiation sweep across space like enormous cosmic lighthouses. Whenever one of those beams crosses Earth, our telescopes detect another pulse. Tick, tick, tick. Nature had built a clock more precise than anyone imagined possible. Another extraordinary discovery arrived decades later. Astronomers found planets orbiting one of these pulsars. At first glance, the idea seemed absurd. How could planets survive the catastrophic explosion that destroys their parent star? Or if they formed afterward, how could they assemble in such an extreme environment? Yet there they were, quietly circling one of the most violent objects in the universe. Once again, reality had ventured somewhere imagination rarely dared to follow. Then, there are the so-called super-puff planets. These distant worlds possess sizes comparable to Jupiter, yet astonishingly little mass. Imagine constructing a planet roughly as wide as Jupiter, but so light that its average density becomes less than cotton candy. It almost sounds like a joke. If placed into an unimaginably enormous ocean, such a world would theoretically float. Of course, no ocean remotely large enough exists. But the comparison reveals just how surprisingly delicate these planets appear. Scientists are still trying to understand exactly how they formed and how they maintain such enormous, extended atmospheres without simply drifting apart. Nature continues keeping some of her favorite secrets. Black holes themselves once belonged to the category of impossible objects. Long before anyone observed one directly, the very idea seemed outrageous. How could gravity become so powerful that even light could never escape? Light was supposed to be the fastest thing in existence. Surely nothing could imprison it. Yet Einstein's theory of general relativity quietly suggested otherwise. Years later, observations began revealing objects whose invisible presence could only be explained by black holes. Today, astronomers have photographed the glowing material surrounding two supermassive black holes. The impossible gradually became familiar. Perhaps the most astonishing lesson is how quickly impossible ideas can become ordinary knowledge. Children today learn about black holes in school. They grow up hearing about neutron stars, gravitational waves, and planets orbiting distant suns. Concepts that would have sounded almost magical to previous generations now belong comfortably within modern science. One wonders what today's impossible discoveries might become tomorrow's textbook lessons. The universe seems wonderfully patient with expanding our understanding. Sometimes entirely new classes of objects appear unexpectedly. In recent years, astronomers have identified mysterious phenomena that brighten briefly before fading away, unlike any known kind of stellar explosion. Others produce repeating bursts of radio energy, lasting only tiny fractions of a second. These enigmatic events, called fast radio bursts, remain one of astronomy's greatest ongoing mysteries. Some repeat, others never do. Scientists continue searching for their true origins. The answers may reveal entirely new kinds of cosmic objects we have not yet imagined. Perhaps that is one of the most exciting aspects of astronomy. Unlike many fields of knowledge, it still contains enormous blank spaces, entire chapters waiting to be written, entire families of objects waiting to be discovered. Every new telescope expands our vision just a little farther. Every improvement in technology allows us to notice details that previous generations could never have seen. And every so often, something appears that simply refuses to fit. At first, scientists question the instruments, then the calculations, then the assumptions. Eventually, if enough evidence accumulates, something extraordinary happens. The universe does not change. Our understanding does. Perhaps this is one of the quietest forms of scientific progress. Not proving ourselves right, but allowing ourselves to be gently corrected by reality. The cosmos has never been interested in meeting our expectations. It has no obligation to remain simple, or predictable, or convenient. Instead, it continues creating astonishing objects with remarkable creativity. Stars that pulse with the precision of clocks, planets lighter than anyone thought possible, invisible black holes bending space itself, ancient remnants spinning hundreds of times each second, and perhaps countless other wonders still hidden beyond the reach of today's telescopes. Somewhere tonight, in a distant corner of the universe, there may already exist an object no human has ever imagined. It quietly follows the laws of nature. It asks for no attention. It shines, or perhaps doesn't shine at all, beneath unfamiliar stars, waiting patiently for its light to arrive, waiting for curious minds to notice, waiting to become the next impossible discovery that reminds us once again that the universe is always a little stranger and infinitely more beautiful than we expect. 10. The universe's slowest travelers. Not everything races through space. Some cosmic travelers drift so slowly that they can spend billions of years between destinations. When we picture a journey through space, speed is usually the first thing that comes to mind. A rocket roaring into the sky, a comet blazing past the sun with a brilliant glowing tail, an asteroid hurtling through the solar system at tens of thousands of kilometers every hour. Even the planets themselves never stop moving. Earth races around the sun at nearly 30 kilometers every second. Meanwhile, our entire solar system quietly orbits the center of the Milky Way at more than 200 kilometers every second. Everything seems to be in motion. Everything seems to be rushing somewhere. The universe often appears restless, always spinning, always expanding, always racing toward the next moment. But that impression tells only part of the story. Because hidden among the fast-moving worlds and brilliant explosions are travelers of an entirely different kind. Travelers that have mastered the art of patience. Travelers whose journeys unfold so slowly that billions of years may pass before they ever reach another destination. Imagine placing a tiny paper boat onto a perfectly calm lake. There is almost no wind. The water barely moves. Hour after hour, the little boat drifts almost imperceptibly. From the shore, it appears completely still. Yet, if you returned many days later, you would discover it had quietly crossed the lake. Not through urgency, not through great effort, simply through endless patience. The universe has countless travelers just like that. One of the gentlest examples is found in the smallest particles drifting between the stars. Interstellar dust may sound unimportant. Tiny grains no larger than smoke particles. Each one made of frozen water, silicates, carbon, or microscopic crystals formed inside ancient stars. Individually, they seem almost insignificant. Yet together they help shape galaxies. They become the raw ingredients of planets. They scatter starlight into beautiful glowing nebulae. They even carry complex organic molecules across enormous distances. What makes these tiny travelers extraordinary is not their size, it is their patience. Many drift through interstellar space for hundreds of millions of years before becoming part of anything else. Imagine spending longer than the age of the dinosaurs simply floating. No destination, no map. Only gravity gently whispering directions over unimaginable stretches of time. Eventually, one tiny grain may become trapped inside a collapsing cloud. The cloud slowly forms a new star. Around that star, planets begin to grow. The little grain becomes part of a rocky world. Perhaps it settles inside a mountain, or beneath an ocean, or within a grain of sand on a quiet beach. A journey lasting hundreds of millions of years ends in complete stillness. And then, the story begins again. Comets are another kind of patient traveler. Near the sun, they appear energetic. Bright tails stretch across the heavens. Ice vaporizes dramatically. Dust sparkles behind them. But most of their lives are spent very far away. Beyond the outer planets lies a distant region called the Oort cloud. It surrounds the solar system like an enormous invisible shell. Its outer edge may lie nearly a light year from the sun. Countless icy bodies drift there in extraordinary silence. Many require millions of years to complete a single orbit. Some have traveled peacefully through the darkness since the birth of the solar system itself. Imagine waiting several million years simply to visit the inner planets once, then quietly returning to the darkness for another equally long journey. A human lifetime would not even register as a single heartbeat within such an orbit. Perhaps even our own solar system could be considered a slow traveler. It is easy to imagine the sun standing still while the planets circle around it. But nothing in the galaxy truly stands still. The entire solar system moves together around the center of the Milky Way. One complete orbit takes roughly 230 million years. Since the dinosaurs disappeared, our solar system has traveled only a small fraction of its current galactic journey. When the first multicellular animals appeared in Earth's ancient oceans, the sun occupied an entirely different region of the galaxy. Every mountain, every ocean, every living creature. All of us are quietly traveling together through space, even though we never notice the motion. There are travelers even slower than stars. Entire galaxies drift toward one another with astonishing patience. The Milky Way and the Andromeda Galaxy are slowly approaching each other. Gravity has been pulling them together for billions of years. Even now, they continue closing the distance. Yet, the movement is so gradual that the galaxies appear almost perfectly still from one human generation to the next. Only after another 4 or 5 billion years will their graceful encounter finally begin. Their spiral arms will stretch, stars will quietly rearrange themselves. New waves of star formation may blossom, not through sudden violence, but through one of the slowest dances in the universe. Even gravity itself seems to prefer gentle persuasion over sudden action. A passing star may slightly alter the orbit of a distant comet. That tiny change seems meaningless at first, But after millions of years, the comet's path becomes entirely different. A planet may experience minute gravitational nudges from neighboring worlds. Over enormous timescales, those tiny influences slowly reshape entire orbits. The universe rarely needs dramatic forces. Given enough time, even the smallest influence becomes profound. Perhaps the most patient travelers of all are photons released shortly after the universe itself became transparent. About 380,000 years after the Big Bang, light finally escaped into space for the first time. Much of that ancient light is still traveling today. Nearly 14 billion years later, it has crossed almost the entire observable universe. Only now does a tiny fraction finally reach Earth's radio telescopes as the cosmic microwave background. These photons have been traveling longer than galaxies have fully matured, longer than stars like our sun have existed, longer than planets have carried oceans. Their journey has continued almost uninterrupted since the universe was still an infant. What remarkable patience! Then there are the hypothetical wanderers that may never truly arrive anywhere. Some lonely rogue planets drift freely between the stars, as we discovered earlier. Without a parent sun, they quietly circle the Milky Way alone. Some may wander for billions of years without ever passing close to another stellar system. Others could travel until the galaxy itself changes beyond recognition. They ask for nothing. They disturb almost nothing. They simply continue. Perhaps this is one of the quiet lessons hidden throughout the universe. Not every journey is defined by speed. Some are defined by endurance, by persistence, by simply continuing. Human beings often celebrate the fastest runner, the quickest machine, the shortest route. Yet nature frequently accomplishes its greatest work through astonishing patience. A mountain rises grain by grain. A galaxy grows star by star. A comet completes its orbit over millions of years. A single particle of dust becomes part of a living world after wandering across the galaxy. Nothing is hurried. Nothing is wasted. The universe seems wonderfully comfortable with taking its time. And perhaps, as we prepare for the final part of tonight's journey, there is something deeply reassuring about these slow travelers. They remind us that movement does not always need urgency. Progress does not always require speed. Sometimes the longest journeys are also the quietest. A tiny grain of dust, an ancient photon, a lonely comet, a wandering planet. Each continues forward in its own gentle way, never racing, never competing, simply drifting through the endless darkness, one peaceful moment at a time. 11. The frozen worlds waiting in eternal darkness. Far beyond the planets we know, countless frozen worlds wait in darkness, preserving the earliest memories of our solar system. If you were to leave Earth tonight and travel beyond the familiar planets of our solar system, you would eventually pass the orbit of Mars, then Jupiter, then Saturn, with its graceful rings slowly circling beneath the sunlight. Farther still, Uranus would quietly drift through the darkness. Beyond that, Neptune, the last major planet, would mark what many people imagine to be the edge of our cosmic neighborhood. It feels like a natural ending. The planets become fewer. The sunlight grows weaker. The distances become almost impossible to imagine. Surely there cannot be much beyond this point. But the solar system has one final surprise. In fact, one of its greatest stories begins only after the last planet has disappeared behind you. Far beyond Neptune lies a realm where sunlight is little more than a brilliant star, a place so cold that temperatures sink to hundreds of degrees below freezing, a place where countless ancient worlds have spent billions of years waiting in almost perfect silence. These are the frozen worlds of the outer solar system, quiet, patient, almost untouched since the earliest days of our sun. Imagine opening a time capsule buried beneath the ground. Inside, every object remains almost exactly as it was when someone carefully sealed it away decades earlier. Letters have not faded. Photographs remain untouched. Tiny everyday objects quietly preserve memories from another age. Now imagine a time capsule not decades old, but more than 4.5 billion years old. That is, in many ways, what these distant frozen worlds truly are. Long before Earth possessed oceans, before mountains rose from its surface, before the moon had fully settled into its familiar orbit, the young solar system was a chaotic place. Countless rocky fragments collided with one another. New planets slowly gathered from enormous clouds of dust and ice. Gigantic impacts reshaped entire worlds. Gravity constantly rearranged everything. It was a remarkably busy time. Yet not every piece of the early solar system became part of a planet. Some remained small, some drifted outward, some found quiet, stable orbits far beyond the giant planets. There, something extraordinary happened. Time seemed to slow. Far from the warmth of the sun, change became incredibly rare. The ice remained frozen, the rocks barely weathered, without flowing rivers, without thick atmospheres, without active volcanoes reshaping their landscapes. These tiny worlds preserved much of their original appearance. They became living fossils of the solar system itself. Today, astronomers know this distant region as the Kuiper Belt. Unlike the familiar asteroid belt between Mars and Jupiter, the Kuiper Belt is vastly larger. It stretches across billions of kilometers beyond Neptune's orbit. Within it drift countless icy bodies. Some are only a few kilometers across. Others grow hundreds of kilometers wide. A handful, including Pluto, became large enough for gravity to gently shape them into nearly perfect spheres. Each follows its own quiet path around the sun. Some complete an orbit in a few hundred years. Others require much longer. Every journey unfolds with remarkable patience. The sunlight reaching these worlds is astonishingly weak. If you stood on Pluto at noon, the sun would appear little more than an exceptionally bright star. Its warmth would be almost impossible to feel. The daylight would resemble a dim twilight on Earth. Shadows would still exist, but everything would seem subdued, quiet, gentle. Even the sky itself would possess a strange beauty. Because sunlight is so faint, the colors of the distant landscape would appear soft and muted beneath the endless darkness surrounding the little world. Yet, despite their isolation, these frozen bodies are far from lifeless in a geological sense. When the New Horizons spacecraft flew past Pluto in 2015, scientists expected to find an ancient world covered almost entirely with impact craters. Instead, they discovered something surprisingly youthful. Towering mountains made of water ice, enormous plains of frozen nitrogen, slow-moving glaciers creeping almost imperceptibly across the surface. The heart-shaped region, known as Sputnik Planitia, looked remarkably smooth, suggesting that geological activity had continued much more recently than anyone expected. Even here, nearly 6 billion kilometers from the sun, nature had not completely fallen asleep. Other distant worlds tell equally fascinating stories. Some rotate sideways, others possess tiny moons. Several have unusual reddish surfaces coated with complex organic compounds formed by billions of years of gentle radiation from the sun and passing cosmic rays. These materials, known as tholins, slowly accumulate over immense periods, painting many distant objects with warm copper and crimson colors. It is almost as though the darkness itself has quietly left its signature upon them. Far beyond the Kuiper Belt lies an even more mysterious region, one so distant that no spacecraft has ever reached it: the Oort cloud. Unlike the flat disk of the Kuiper Belt, the Oort cloud may surround the solar system in every direction, like an enormous invisible sphere. Its outer edge could extend nearly halfway to the nearest star. Inside this immense frontier drift trillions of frozen objects. Most are thought to be leftovers from the birth of the solar system, gently scattered outward by Jupiter, and the other giant planets billions of years ago. Since then, they have simply waited. Occasionally, a passing star or the gentle tides of our galaxy disturb one of these sleeping travelers. Its orbit slowly changes. Gravity nudges it inward. After perhaps millions of years, it begins an extraordinary journey toward the inner solar system. Eventually, sunlight warms its frozen surface. Ice begins turning directly into gas. A glowing coma appears. A magnificent tail stretches across the sky. A comet is born. When we admire a comet crossing Earth's heavens, we are witnessing an object that may have spent almost the entire history of the solar system asleep in deep darkness. Its brilliant display lasts only a tiny fraction of its incredible existence. For billions of years, it remained hidden beyond the planets, patiently preserving ancient ice that formed before Earth had fully become the world we know today. Perhaps that is why scientists treasure these frozen worlds so deeply. They are not simply distant objects. They are archives. Their ice traps ancient molecules. Their surfaces preserve collisions from long ago. Their chemistry remembers conditions that disappeared from the inner solar system billions of years ago. In many ways, they remember a childhood that the planets themselves have largely forgotten. Earth has changed enormously since its birth. Continents drifted, oceans formed, life transformed the atmosphere. Countless geological processes erased much of the evidence from its earliest history. But these frozen worlds, they remained quietly waiting, patient custodians of ancient memories. Even now, as we continue our peaceful journey through the universe, countless icy bodies drift silently beyond Neptune. Some have never been visited. Most have never even been seen directly. They simply continue circling the sun beneath skies that never know warmth. Perhaps they will remain there long after humanity has finished telling its own story. Still frozen, still silent, still faithfully carrying the earliest memories of our solar system across the endless darkness. And perhaps there is something wonderfully comforting about knowing that, even in the coldest and most distant corners of our cosmic home, time has carefully preserved small pieces of the beginning, waiting patiently for curious minds to one day discover them. 12. The last things that will exist. Long after every star has faded and every planet has gone silent, a few lonely objects may still remain in the darkness. If these gentle explorations help you end your day with a little more wonder, consider subscribing, and I'll be here for our next quiet journey through the universe. Every story has an ending. A campfire slowly fades into glowing embers. Autumn leaves eventually fall from the trees. Even the brightest sunrise quietly gives way to evening. Nothing in nature seems designed to last forever. For as long as humans have looked toward the stars, we have wondered whether the universe itself is any different. Will the stars always shine? Will galaxies continue creating new suns forever? Will planets endlessly circle their parent stars beneath familiar skies? Or will there come a day when even the universe grows quiet? The answer, according to our best understanding of modern cosmology, is both beautiful and deeply humbling. The universe is not immortal. Neither are its stars. Even the greatest galaxies will one day become silent. But strangely enough, when almost everything else has disappeared, a few lonely travelers may still remain, patiently drifting through an ocean of darkness, waiting long after the final sunset. If someone could somehow leap unimaginably far into the future, the universe would already look unfamiliar. Billions upon billions of years from now, the great stellar nurseries we explored earlier will have almost exhausted their supplies of cold hydrogen. The glowing clouds that once gave birth to brilliant new stars will gradually disappear. One by one, galaxies will stop creating fresh generations of suns. Not because something catastrophic happened, not because of a single great disaster, simply because the raw material has slowly been used up. The universe has always been generous, but even generosity has limits. Every new star requires hydrogen. Every brilliant sunrise somewhere in the cosmos begins with enormous clouds of gas collapsing under gravity. Eventually, those clouds become fewer, then fewer still, until one day, the birth of new stars becomes an extraordinarily rare event. Imagine walking through an ancient forest at the end of autumn. For centuries, new trees grew every spring. Old ones quietly fell. The forest remained alive because new life constantly replaced the old. But now, no new seeds take root. The oldest trees continue standing, yet each year there are slightly fewer of them. The forest grows quieter, not suddenly, but gently, patiently. That may be the future of the cosmos itself. The largest stars disappear first. They have always lived remarkable but brief lives, burning furiously, shining brilliantly, ending in spectacular supernova explosions. Smaller stars remain much longer. Yellow stars, like our own sun, survive for around 10 billion years, but even they cannot shine forever. Eventually, the sun will exhaust the hydrogen deep inside its core. Its outer layers will slowly expand. For a brief cosmic moment, it will become a red giant. The inner planets will no longer resemble the peaceful worlds we know today. Afterward, the sun will quietly shed its outer atmosphere into space. At its center, a tiny white dwarf will remain, a stellar ember, no longer creating new energy through nuclear fusion, simply glowing from the immense heat left behind. Over unimaginable spans of time, even that gentle glow will slowly fade. Not over millions of years, not even billions, but trillions upon trillions of years. Long enough that today's universe would feel almost unimaginably young by comparison. Yet even after ordinary stars disappear, the one remarkable family of stars refuses to surrender: the tiny red dwarfs. Earlier tonight, we learned that these quiet little stars burn their fuel with extraordinary patience. Unlike massive blue stars that race through life, red dwarfs seem content to whisper rather than shout. Some may continue shining for 10 trillion years, others perhaps even longer. In fact, the universe today is simply too young for any naturally formed red dwarf to have died from old age. Not one. They are still quietly living out the earliest chapters of incredibly long lives, far beyond the era of galaxies filled with brilliant young stars. The red dwarfs will continue glowing, tiny islands of warmth scattered through an increasingly silent universe. If any civilizations exist during those unimaginably distant ages, these humble little stars may become their last dependable suns. Eventually, however, even the red dwarfs must surrender. The final stars fade. The last sunsets come and go. The great age of starlight quietly reaches its conclusion. No new dawns appear. Galaxies become collections of dark stellar remnants drifting beneath endless night. White dwarfs, neutron stars, black holes, cold planets, frozen moons, comets sleeping forever beneath skies without sunlight. The universe enters what astronomers sometimes call the degenerate era. It sounds dramatic, yet in many ways, it may simply be peaceful. Nothing rushes, nothing burns. Only gravity continues performing its slow, silent work. Some planets may continue orbiting dead stars for astonishing lengths of time. Imagine standing on one of those frozen worlds. The familiar sun has vanished. The sky is filled only with distant galaxies, themselves growing fainter as the universe expands. No mornings, no evenings, only the endless quiet of cosmic midnight. Perhaps beneath thick layers of ice, tiny pockets of warmth remain. Perhaps not. The universe does not promise that every story ends with light. Sometimes, silence becomes the final chapter. Among the last luminous objects may be white dwarfs slowly cooling toward complete darkness. Astronomers sometimes imagine what happens when one finally loses the last trace of stored heat. It becomes something that has never yet existed. A black dwarf, not a black hole, not a star. Simply the cold remains of a star that has spent trillions upon trillions of years quietly cooling. Curiously, the universe is still far too young for even one black dwarf to exist. None have ever formed. Every white dwarf we observe tonight is still slowly releasing ancient warmth. The first true black dwarf belongs entirely to the future. Perhaps no human mind will ever witness one. Yet, the laws of physics quietly suggest they are waiting, patiently. Then there are the black holes. For many people, they seem eternal, immovable giants capable of surviving anything. Yet even black holes may not last forever. According to the remarkable work of Stephen Hawking, black holes slowly lose tiny amounts of energy through a process now known as Hawking radiation. The effect is unimaginably small. For stellar black holes, it is completely undetectable today. But over astonishing spans of time, long after every ordinary star has disappeared, even these cosmic giants slowly begin to evaporate. The largest black holes may require around 10 to the power of 100 years or even longer before finally disappearing. That number is so enormous that writing it out would require 1 followed by 100 zeros. Human language almost stops being useful. Time itself begins losing familiar meaning. Yet even that incredible patience has an ending. The last black hole quietly fades. No explosion, no grand finale, only one final whisper of radiation escaping into the darkness. So what remains? Perhaps little more than lonely particles drifting through an ever-expanding universe. Ancient photons stretched into unimaginably long wavelengths. Electrons, positrons, neutrinos. Perhaps dark matter continuing its invisible journey. Perhaps even those will slowly transform in ways we have not yet discovered. Modern physics still does not know every answer. Some theories suggest the universe may continue changing forever. Others imagine entirely different endings. The truth remains one of science's greatest unfinished stories. And perhaps that uncertainty is strangely comforting. Throughout tonight's journey, we have visited invisible oceans, sleeping galaxies, lonely rogue planets, ancient light still crossing the cosmos, frozen worlds preserving forgotten memories. Each reminded us that the universe is far larger, quieter, and more patient than our everyday lives allow us to imagine. Yet the final lesson may be the gentlest of all. Nothing lasts forever. Not stars, not galaxies, not even black holes. And somehow, that does not make the universe feel smaller. It makes every moment of light feel infinitely more precious. Every sunrise, every clear night, every quiet glance toward the stars becomes part of a story that has been unfolding for nearly 14 billion years. A story we are fortunate enough to witness for one brief, beautiful chapter. Tonight, somewhere above us, ancient starlight continues arriving after journeys longer than the history of life on Earth. Some distant galaxy quietly gives birth to another star. A lonely comet drifts patiently through the darkness. A frozen world keeps its silent memories. And far beyond anything we can ever reach, the future waits with extraordinary patience, one peaceful moment at a time. If these gentle explorations help you end your day with a little more wonder, consider subscribing, and I'll be here for our next quiet journey through the universe.